Welcome back, students. I am Sudipto Karmakar, Assistant Professor of Physics, SVIST. And in today's class, we are going to solve a problem from the chapter vector. This problem came in the year 2022-23 even semester in MAKAUT, and the problem says, give the physical significance of the curl of a vector and also show that f vector equals to 2xy plus z cube I cap plus x square j cap plus 3x z square k cap is a conservative force field. So let's start. To solve this problem, we have to give the physical significance of any vector field. Now, what is the physical significance of curl of any vector field? The curl of any vector field f is defined as delta cross f. It represents curl of vector f. Now, curl represents the rotational tendency or the rotational tendency of any vector field or any vector f at a particular point. If the curl of any vector is 0, it represents the vector has no rotational tendency at a particular point. And if the curl is non-zero, then obviously it has a rotational tendency at any particular point. Okay, so we may conclude that the physical significance of any curl of any vector field, that is, if curl of any vector field f, it is 0 vector, that means obviously the operation leads to that the operation gives us a 0 vector. If it is true, that means if curl of f is 0, then it represents f vector is irrotational. F vector is irrotational. It also signifies that f vector is a conservative vector field, and f vector is a conservative vector field. Okay. Now, if curl of vector f is not 0, it is non-zero, then it represents f vector is rotational, and it also signifies that f vector is non-conservative. It is a non-conservative vector field. Okay, so this is the physical significance of curl of any vector. Now we have to show that the given vector field, that is f, is a conservative vector field. So from this definition, we have to show that the curl of this vector will be 0. If it is 0, then obviously it signifies that f vector is a conservative vector field. So let's start. So we have our vector f vector, that is 2xy cap plus 2xy plus z cube. So this is x component. So we have to take curl over this vector field. So curl of f vector, that is equals to determinant I cap, j cap, k cap. We have curl, that means it is a gradient operator or curl operator, so we have to write it as del del x, del del y, and del del z. Now we have to write all the components of f vector, that is the x component of f vector, it is 2xy plus z cube. 2xy plus z cube. Now what is its y component? Its y component is x square, and its z component is 3x z square. 3x z square. Okay, so we have to solve this determinant. So it results the I cap component, that is del del y, it is going to operate on 3xz square minus del del z, it is going to operate on x square plus j cap. If we have the j cap component of the curl, then it results del del z is going to operate on 2xy plus z cube minus del del x, it is going to operate on 3xz squared. Now what about the k cap component? K cap component is del del x, it is going to operate on x square, and similarly del del y, it is going to operate on 2xy plus z cube. Okay, now we have to solve these all differentiations. So let's talk about the I cap component. So here we have partial derivative with respect to y, that is going to act on 3xz square. As you can see in this particular term, there is no y. So this total term will be taken as constant if we are going to operate partial derivative with respect to y. So it leads to 0 minus, let's talk about the second term. Here we have del del z, that is partial derivative with respect to z, that is going to act on x square. Obviously, it also results 0. Plus, what about the j cap component? Here we have del del z, that is going to act on 2xy plus z cube. As 2xy, there is no z, so this term goes to 0. Now, what about this term plus z cube? Del del z, it is going to operate on z cube, so it results 3 z square minus del del x, it is going to operate on 3x z square, so it simply leads to 3 z square. What about the k cap component? In k cap component we have del del x, it is going to operate on x square, so it results 2x minus del del y, it is partial derivative with respect to y, that is going to act on 2xy plus z cube. So obviously the first term gives us 2x, and in the second term we have z cube. If we take del del y, that is partial derivative with respect to y, that is going to act on z cube, so it simply results 0. So this leads to I cap 0 plus j cap, as you can see, plus 3z square and minus 3z square, these two terms cancels out, that gives us 0, plus k cap, we have 2x minus 2x, obviously these two terms cancels out, so it results 0. So as a result we have 0 vector. So on the left hand side we have curl of f, that results 0 vector. Therefore curl of f is 0 vector, and since the curl taken on the f vector is 0, so we can conclude that f vector is a conservative vector. So hence that statement is true, that is f vector is a conservative vector field. So thank you for watching. See you in the next video.